My name is Chen. I'm from Dell. So I joined Dell in year 2004, and then I actually spent the first 6 years in Dell Financial Services. Myself, actually, I have a Ph.D. in statistics. That's what Professor called statisticians last night. And then in year 2010, actually, I moved to from Dell Finance to Dell Marketing. And then in year 2011, actually, I was just like everyone here, sit the table and then listen to a 9 lecture in the Bayesian network. So starting from year 2009, Dell Marketing actually conduct a series of experiments to understand how statistical models or any machine learning type models can help CMO to make the marketing decision, especially for allocating the marketing resources. And then that's the reason that's where Bayesian network come in. And so before I actually go to the detail, I would like to introduce you Dell as a company. So many people might know actually Dell is a PC company, but many people probably didn't know in the last 7 years, Dell actually has transformed into end-to-end solution companies. So many people don't know we actually build data centers for Amazon, Google, Microsoft, Facebook, Twitter. And many people didn't know Dell actually is for the middle tier storage system, Dell actually is the market leader. And then we also acquire a lot of software companies. So right now, Dell is no longer just a PC company. So if you look at the revenue from both sides, client product and enterprise product, probably around year 2006 to 2008, 70% of Dell's revenue actually came from client products like PC, desktop, workstation. But probably after 2012, even up to this moment, actually the revenue actually is kind of flipped. So 60% of their revenue right now actually came from enterprise products, software, storage, networking, and then more than 70% of the margin actually come from enterprise products. So I guess every CMO would like to know, right? So what is the ROI for the marketing investment? So again, those two tables, just for illustration purposes, is not the actual figure. So imagine this. So in year 2011, or sorry, in year 2013, we spent $100 million in marketing. But in year 2014, we actually spent a little bit more, $10 million more. But if the Dell revenue actually increased from $1 billion to $1.4 billion, if the story stopped here, every CMO would tell a very good story. Hey, you know what? Give me more money, invest in marketing, and we can boost Dell's revenue. But is it true? Probably not. How about we just go to a different conference room, and sales directors will give you totally different answer. Sales directors will tell you, hey, you know what? It's not a marketing. I show you the marketing mix. It doesn't seem to me the contribution is from marketing. And where is the contribution of that $0.4 billion? Sales director will tell you, hey, you know what? It's sales. It's because you increase the sales headcount. So we help you to push more bucks. That's sales. But is it true? Is it sales? If you talk to supply chain, if you talk to product group, they will give you very, very different answer, and based on their perspective. So that's the reason why. So traditionally, the so-called marketing mix model no longer serve for to answer this type of question. So starting from year 2010, internally we actually select a elite group and try to use different methodologies to tackle and answer these questions. How we are able to better allocate Dell's internal budget, not just marketing. So some people call it marketing mix model instead of traditional media mix model. In Dell, we actually call it a corporate mix model. So we began to collect a lot of data. So from different departments. So internally for marketing, actually, it's much easier to get, right? So, but we also collect the data from product group, supply chain, enterprise group, client group, finance, even human resources. So we collect more than 1,000 variables, and then we actually reach out to many different data owners as well, actually more than 100 POCs, and across 10 different data systems. So you might think, actually, it's how come a high-tech company would have 10 different data systems, but it actually happened in Dell. So it probably happened in all the company as well. So we have a centralized database. We actually use Teradata. But before we use Teradata, we actually use Oracle. So, but a lot of data, we are not able to fully migrate from Oracle to Dell, because some financial transaction data actually is, we find out that Oracle probably is better to handle that kind of transactional data. So we have Oracle, we have Teradata, we have SQL Server, we also have SharePoint, Salesforce.com, and some cloud solutions. And then we also have some data vendors as well, like Experian, DMB, Equifax, and Hard Hands. So after we collect those data, and we begin to think about how we are going to use those information. Right? So we have sales investments, we have product innovations, we have supply chain ship-to-command accuracy, we have marketing spend, product quality, and pricing from the finance group. So how we are able to blend those information together, probably plug into a mathematical formula, and then I can do attribution. And then I will know actually which departments contribute how many percentage of their revenue. And then I will know how I can optimize those different investments within Dell. So the tool we use, actually, the project actually goes through many different stages. Right now, we're actually in the stage 4. So we actually introduce Bayesian network in the first and second stage. And actually, we actually move forward and then use the other tools like SAS and R. So in the central, actually, is the target variable, which is their revenue. And we try to build up different nodes, not 10 variables, try to explain their revenue. Use the previous variables we collect. I try not to get too detailed because before I can make any presentation, there's a legal team actually censor all those presentation decks. So they actually asked me to take out all the formulas. Basically, I do not have any proprietary. All the proprietary actually belong to Dr. Nino. I just have trade secrets, a lot of trade secrets. But sorry, I cannot tell too much here. And here comes the end result, right? So the one here actually on the left-hand side actually is Dell's previous revenue, right? And then we have the ending revenue. For example, if it's 2013, there will be a 2014 revenue. And we will try to explain, use all the information we collect, right? Those different KPIs across different departments. We try to explain how come the revenue grow or revenue drop. So we can actually attribute those revenues into social media, customer services, sales pricing, so on and so forth. Economies even, right? So in a good year, when our GDP is actually growing, presumably their business also will grow.
So what's this chart? So this is, say, over a quarter or
it's over a year.
Over a year. There's been a change in revenue, and then you're attributing, social media contributed to an increase, product innovation contributed to a decrease.
Mm-hmm.
And if you add all these up, then it's the difference in your revenue year over year.
Yes.
Okay.
Yeah. So we try to build up the attribution model.
Okay.
So when there's revenue drop, we will know who we should brand for.
So the rows in the data set, are those product in month, or what does that look like?
So we collect the time series data, so it will be on a weekly format. So for example, pricing will be our discount percentage on a weekly basis based on different product types. And sales, of course, is weekly. They are sales headcounts. And then here's the other example. What if the revenue actually stay flat, right? We can also see through the Bayesian network model. We can also see the attribution from different categories, different variables. So we use this model a lot, use the modeling result a lot to actually try to come up with the internal strategy. So couple key findings. For example, previously in the supply chain, we always try to push our logistics team to deliver product as soon as we can. Right. So for example, you will order a PC, and it probably will, before you check out, their system will tell you the expected delivery date, right? So let's say expected delivery date is actually next Monday. Their logistics team, previously, they will try to deliver a product even before Monday, even before the day I promise you. So they will try to deliver, for example, like Friday on Saturday. But we find out, actually, through the data, we find out if we deliver sooner than what we promise, actually our customers' satisfaction actually drop a lot. It makes sense though, because maybe when I tell you the expected delivery date, you actually set up your schedule or whatever accordingly, right? So you will stay at home on Monday, and you probably will go out of town Friday or Saturday. But when we deliver, you actually just miss it. So the idea is actually pretty simple, right? So, but the execution actually is quite complicated in our case here. And here comes the raw X, or ROI figure for different departments. So sales actually is contribute 0.9x, right? So for every $1 I invest in sales, I get $0.9 back. Not a very good investment. But for marketing, yes, it's 1.3. And pricing and marketing brand, especially for a marketing brand, product as well. And pricing, we find out actually, when we actually discount the price a lot, it hurt their brand. And if it hurt their brand, it actually will lower the baseline in the model. The intercept will be lower, much lower. So we find out actually the pricing probably for the short term, it's a very good weapon, but for the long term, it will hurt company's image.
Question?
Yes, please.
So given your previous slide,
Previous slide.
so if these are marginal returns, why would you invest in anything other than product? Why wouldn't you just put all your money into the thing that gives you 2.5?
So if you believe, so which we believe, so every variables in our model, they have it's like in the market width model, it's an efficient frontier, right? So you cannot keep invest in one particular vehicle unlimitedly, because sooner or later you will hit diminishing return. So that's the reason why after we use the Bayesian network to build a model, we have another tool to do the optimization. Yeah, so maybe you see the product actually is 2.5x. Okay, invest all the money to the product group, but sooner or later you will hit a saturation point, and then the return on investment ratio will drop. So we just need to find the equilibrium. Any questions so far?
So you mentioned efficient frontier. So you're treating this like a portfolio and saying, what's the
Yes, it's a portfolio model.
Have these in the right mix so that you
Yes.
you have products to market, but you also have but you also have to have some market weight behind them, and you have to have some sales team. You have to keep them in some sort of ratio to give you a good return.
Yep. And for example, the sales headcount here is actually even below 1 actually. So does that mean we need to cut sales? Maybe, but we still need sales no matter what.
But you imagine there are interaction effects anyway, right? So
Yeah. So basically, this model provides us very good directional guidance. For example, Michael Dell always has this question to his executive leadership team. So they say, if I have $10 million extra, $10 million, where I should put my money? Should I actually buy more TV commercial? Or maybe I invest in hire more sales representatives to do maybe better customer services? Or maybe I put it into a product group to develop the next generation server. So this model can provide at least some directional guidance to such questions. So my intention actually is try not to actually tackle too detail on the technical side, because I know last night we already have quite technical discussion with Professor. So I intentionally to provide this step actually focus more on the application. So here comes the detailed calculation from the previous slide. So for sales, we actually have a lot of different variables across different departments. And then we sum it up together, put into the same category, and calculate the ROI at the summary level. So when I actually joined the team, my team actually is marketing decision science. And I joined the team in year 2012. So when I was in 9 months training in Atlanta, Georgia in 2011, I was not the member of marketing decision science. At that time, I was with marketing operation in North America team. But I constantly serve as the trust advisor to this group. So that's also the reason why they decided in 2012, the CMO decided to move me to the marketing decision science. So before I actually officially joined the team, this team actually tried different other methodologies to build this corporate mixed model. So I remember at that time, the very first methodology we used actually is structural equation model, which is Professor mentioned last night as well. It turned out not to be very successful. And then we also try some Bayesian approach at the early stage, but find something, but not very useful. Not until we have the Bayesian network. So a couple of reasons we actually, so the team consider Bayesian network. So first, we need to handle very high dimensional data, right? But in classic statistics approach, we always will run into trouble to tackle high dimensional data. There are many ways to do it, right? So we have we have GLM lasso, we have GLM NOT, and then we have ridge regression. But by far, we are not able to keep multi-collinearity at bay because all our stakeholders, they would like to see their variables, their attributes in the model. But in order to actually incorporate those many variables, traditional statistical approach is just difficult. And the other thing we consider Bayesian network is it can draw the causality, which is a lot of business leaders would like to see. So with all those different factors put on the table, so at the stage 2, we actually retire the structural equation model and move into the Bayesian network environment. And in the stage 3, we actually kind of move it to another direction. We actually introduce the time series model. And then currently, we actually use kind of in conjunction with the Bayesian network, but we actually incorporate a lot of Bayesian inference, Bayesian statistics, like those Pro-MCMC and Pro-model in SAS, try to get a better estimate on the coefficient to help us to get better optimization results. So we basically use a lot of tools in-house. So we have SAS, we have R, we have Bayesian network, and we also have MATLAB, and we also just acquire statistical package company named StepSoft a couple months back. So right now we also have a StepSoft. So basically, all my team members, we have 20 plus team members in Bangalore, India, and we have 3 team members in the US. We have 3 Ph.D.s and use all those different type of tools to build this model. That's where we are right now. So that's being said, I conclude my presentation.